Hey everyone, this is Karthik and this video will be about another DP problem that comes from the CSES section, counting numbers. So before I actually start the video guys, make sure that you like, share, subscribe, comment, whatever you can do unless you want me to start making roadmap videos. Make sure guys that you like the video, subscribe to the channel and help me with the YT algorithm so that at least so I do get some audience. So let's start with the video now. The problem is counting numbers from CSES problem set. It is a direct application of digit DP. If you've seen my introduction to digit DP video, I recommend that you try to solve this on your own because it should be easy for you to solve it because the problem is a very standard application of digit DP. So the problem says that you're given with two integers small a and small b. You would like to find out how many integers are there in this range from small a till small b which follow a certain property. And what is that property? So if there is an integer x in the range a to b, no two adjacent digits of x should be the same. That's it. That's the property that x needs to obey to be counted as a valid number. I need to find out how many valid numbers are in this particular range. Let me take an example. So for this example, 123 and 321, there are 171 such numbers. We cannot validate that example because at least I am human. So I'll take a smaller example of 11 and 16. 11 is not a valid number because there are two digits 1 and 1 which are adjacent to each other and same. So 11 is not a valid number, but 12 is because 1 and 2 are different. 13 is, 14 is, so until 16 is also a valid number. So there are going to be exactly 5 valid numbers in this range, right? Okay. Let me take one more example. Is 1, 2, 3, 2, 1 a valid number? Yep, it is a valid number because you cannot find any two adjacent digits which are the same. But if we talk about 1, 2, 2, 2 and 1, this is not a valid number because these two adjacent digits are same. So are these two. Alright. So hope you get the idea of the problem statement. Let's move to the solution now. A brute force solution is simply to iterate from A to B and find out the answer, but that would be big O of B in complexity. Right? That would be this much in complexity and that's going to be about 10 power 18 operations at first. So we'll not go forward with this and we'll think about a better solution now. Yep, I'm recording. So if you've seen my digit DP videos, the basic idea is to split the problem into two cases. Instead of solving from for this range, I would rather solve it for this range. I would solve it for the range 0 to b and then I would solve it for the range 0 to a minus 1 and then my final answer is this. That's the basic standard idea here. Okay. But now the question is how do you solve for this range? If you're able to solve for the range 0 to b, the other is going to be identical. The solution will be identical. Let's focus on focus on the fact how to solve for 0 to b. Let's say that b has n digits. Right, b is an n digit number. So I can reformulate the problem as finding out how many n digit numbers are there that are less than equal to b and obey that particular property of being valid. Okay, so this is an n digit number. Let me take an example of b as 8, 7, 3, 6 and maybe 5 or 2. Okay, let's say b equal to this. I need to generate n digit numbers which are less than equal to small b and obey the valid property. I need to count how many such numbers are there. So also we will take 0 as an n digit number by putting some leading zeros, right? So this is an n digit number. This is 0, but I'll consider this to be an n digit number. Similarly, 1 is an n digit number, 2 is an n digit number, and so on till all the numbers are n digit number up to this. All the numbers in this range are n digit numbers, right? So let's forget about keeping our number less than equal to b. Let's think about the problem without that constraint. Let's say there is no constraint. I'm just trying out to generate all the possible n digit numbers. In that case, I would generate some extra numbers that are greater than 8, 7, 3, 6, 2 and but definitely less than equal to 9, 9, 9, 9, 9, 9, 9, right? So in that particular case, when I do not think about that, let me just wipe this away. Yep. So if I do not think about this, I'm going to define my DP as this. I'm trying to find out all the n digit numbers that are, I'm just thinking about only n digit numbers that follow a certain property. follow property that no two adjacent digits are the same, right? This is my DP of n. So take this to be your n digit number. Think about what digit comes in here, right? I can put in a 0 here and then think about how many n minus 1 digit numbers exist that follow this given property. Or I can put in a 1 here, 2 here, so on. But there's one important thing to notice. If you put in a 1 here, now you're thinking about n minus 1 digit numbers that follow a certain property, right? But this leading digit here for this n minus 1 digit number cannot be equal to 1. So I need to define my DP like this. DP of n minus n comma x. How many n digit numbers exist so that the leading digit is not equal to x? That's the idea of DP nx. Follow the property that no two adjacent digits are the same and leading digit is not equal to x, right? Because if you put in a 1 in here at this position, now you try to find out how many n minus 1 digit numbers are there that follow the given property. You need to make sure that this digit is never a 1, because if this is a 1, then you have already violated the property. Similarly, you cannot put in a 1 here for sure, but you can put in a 2 here or a 0 here. Let's say you put in a 2 here. Then you need to find out how many n minus 2 digit numbers exist that follow this given property of no two adjacent digits being the same, given that this leading digit here is not 2. Okay, that's the basic idea of DPNX. And if you think about it, your final answer is going to be nothing but, if B had n digits, then count of n digit numbers that follow this given property is DP of n comma let's say 10 or minus 1, because initially any digit could be the leading digit, right? You could have put in a 1, 2, 3. There is no constraint initially. So at the leftmost position, any number could come. Now, there is one more interesting thing that you need to take care before we actually move on to coding it up, is that also currently I'm generating numbers that are greater than small b also. I'm generating all the numbers in the range 0 to n times 9. Okay. Now, if I put in a 0 at the leftmost position, what happens is that at this position, I can still put in a 0 because my number has not actually started yet. Right, my number hasn't even started yet, so these zeros don't actually matter. These are the leading zeros, so I need to keep in another variable to keep track of the leading zeros. Okay, so DP of, I'm trying to find out DP of n. Leftmost digit should not be equal to minus 1. Minus 1 is obviously an invalid digit. And am I still putting in leading zeros? Because if I'm still putting in leading zeros, in that case, I can still put in a 0 even if the previous digit was a 0. DP nx, x was the previous digit, the digit just left to this particular position, I had placed an x. But if I'm still putting in leading zeros, then it doesn't matter. I can still put in a 0 again, right? That's the basic idea of this thing. Okay, and finally, one last thing to make sure that we stay under b. How do we do that? We keep another Boolean variable. A Boolean variable, namely tight, tells you whether it's possible in the future to exceed b or not. So if tight equals to 1, this means that you need to make sure what is the corresponding digit of b while putting a digit at the current position. So I'll take an example again. Also guys, this tight and everything, this is very standard, and in my introduction to digit DP video, if you go through it, you'll definitely understand in one go. But to keep the duration of this video short, I need to quickly explain these things, right? And while coding up, it will be more clear. So if you feel you don't want to go through that video, it's okay. 87362. Let's say this is your B number and you're generating a 5-digit number. Okay. Now initially at this position, you can put in a 0, good. You can put in a 1, 2, 3, so on till 8. You cannot put in a 9 because currently you're under a constraint that you might exceed B, which you do not want to do. So you always need to think about what is the corresponding digit in B and the numbers that you can put in are from the set 0 till 8. You cannot put in a 9 here. If you put in a 0 here, one thing is that at this position also you can still put in a 0 because these two adjacent digits don't count. These are still the leading zeros, and this boolean variable leading zeros actually signify that. Okay, so let's say you put in a 0 here. Now you can, at this position, you can put in a 0, a 1, a 2, 7. You can even put in 8 or 9. Why? Because now it's impossible to ever exceed b. Even if you put in a 9 here, this number will always be smaller than what b is. So there is no more tight constraint on you since you placed a 0 here. And now you're free to go ahead and put anything. So that tight variable becomes 0. There is no tight constraint on you. Okay. And finally, if you put in an 8 here, you're still under a tight constraint. And you cannot put in any number greater than 7 at this position. You need to think about what's the corresponding digit at b. Okay. But if you put in a 5 here, now at this position you can put in any digit from 0 to 9 except for 5. Why except for 5? Because you are not putting in leading zeros. Leading zeros have been done and the previous digit x is 5. So you can put in a 5 here. Otherwise you violate the constraint that two adjacent digits cannot be the same, right? So you cannot put in a 5 at this position. Guys, with that much intuition, let me define a subproblem as dp of how many small n digit numbers exist, or how many n digit numbers exist, such that this current digit cannot be equal to x. The leftmost digit of these n digit numbers cannot be equal to x. This boolean variable defines whether I'm still putting in leading zeros or not, and finally whether I'm still under a tight constraint or not. So final answer is going to be dp of capital N. This will evaluate how many valid numbers are there in the range 0 to b. So b has n digits. First digit could be anything. So let me put that first digit cannot be -1 because -1 is not a valid digit for a positive number. So I'll say okay, how many n digit numbers exist so that the left extreme digit could not be a -1. I'm still putting in leading zeros because I could put in zeros right now and those will be considered as extra leading zeros, right? So leading zeros is 1 as the boolean variable, and there's still a possibility that I might exceed small b in the future. So tight equal to 1, you need to think about what's the corresponding digit at b, and that's it. This will calculate your answer. Let's move to the coding part now. If you have any doubt, you can ask me in the comments, but while coding up, the recurrences will become much more easy and clear. We'll be doing it top down to make it as easy as possible to understand. I'll be taking in two inputs, A and B. Okay. C in A, C in B, and I'll say okay, solve for B and solve for A. Whatever is the difference between these two, subtract them and output them. Also, how do I calculate how many digits a particular number has? Okay, we'll think about that later, but see, this is what I need to calculate. Pass in the number, pass in how many digits that number has. So digits in B, pass that in. Also pass in the leftmost digit cannot be equal to -1, then 1, 1. Leading zeros is still 1, tight is 1. Okay. Similarly, pass in A-1 because you want to see how many numbers from 0 to A-1 are there that follow the valid the property. See how many digits are there in A-1. Pass that in. Pass in -1 and 1. Subtract these two and get your output. Okay. Let me create this solve function. This is going to return a long. Taken LL, my number, the digits, what digit number I'm trying to produce right now. So I'm trying to produce an n digit number, and then my leftmost digit could not equal to what, that is specified by x. Also, whether I'm still putting in leading zeros or am I done putting in leading zeros. That helps me decide if the previous guy was a 0, can I still put in a 0 here? If leading zeros is 1, then I can still go ahead and put another 0. So leading zeros and another boolean to decide whether I'm under any tight constraint or am I free to put in any digit at this particular position? Okay. So nx, okay, 1. Initially I'm under a tight constraint, and initially leading zeros is 1, x equal to -1. Hopefully this is making sense, guys. Otherwise, feel free to put in a comment. Feel free to criticize. I feel a bit bad though, but make sure that you ask me your doubts in the comments. I'll try to help. So guys, now this solve function is going to work like this. If you're trying to produce in a 0-digit number, then you don't need to do anything, and there's one way of producing a 0-digit number, an empty number, right? So if n equals to 0, if there is no digit in the number, just return 1. There's one way. Don't do anything, and you have produced a valid number, an empty number kind of thing, right? All right. Now I'll see what is the smallest number that can come at this position. I'll try to put in a digit at this position. So let's say ub equals to 0, lb equal to 0, lower bound. The smallest digit that I put in at this position is going to be 0, and the largest digit I put in at this position is either going to be 9, or it's going to be defined by what my number is, right? Okay. Also, it's best if I take a and b as strings, I guess. I guess so, because then it would be easy to see what is the corresponding digit of a number. Otherwise, I'll have to break the number down every time. So how do I convert a C++ integer to C++? I think it's STOI or ATOI. Converting string to number and vice versa. Okay. Sorry about being a noob. Come on, there is a function known as ATOI, I guess. Yep, toString. Is that it? Just toString. Okay, great. So string A is going to be toString A-1, and string B is going to be toString of B. Let me just compile this. Will it work? Digs. Okay, cool. And now I don't even need this digit function. I can just say, okay, b dot length. This is the number of digits in B. Similarly, here I can call a dot length. This is the number of digits in A. Yep. Does this work now? Cannot bind non-const L value. Oh, all right. Let me make this a string, passing it by reference. And I can pass in capital B and capital A respectively. Yep, this should work now. Yeah, cool. So upper bound is either going to be 9, or is going to be controlled by what is the corresponding digit in this number. So for example, if this number is 5, 6, 2, 3 and 9, and if tight is 0, then obviously you can put in any digit at this place. But if tight is equals to 1, in that case you need to find out what is the digit you are filling. Let's say you are filling in this digit, and what is the corresponding digit at this position, right? So your digit needs to be smaller than this guy or equal to this guy. Okay, so ub equals to tight equals to, if tight is 1, if tight is 0, then simply 9. You can go ahead and put any digit as large as 9 at this position. Otherwise, you need to see what is the corresponding digit in this number at this particular position. How do I do that? So let's say if n equals to 3. So I need to find what is in this number starting from the right, 0, 1, 2, the second position, right? If n equals to 3. It's getting a bit complicated though, but fine. It's going to be number dot length minus n. So if n was equal to 3, number dot length would mean the index just past 9, minus 3 would mean here, here and here. Okay, hopefully that makes sense. If it doesn't, then I guess you can try it out on pen and paper. It will make more sense. Now I'll try putting in each digit at this position, meanwhile finding out what my answer is. So let's say my answer is LL answer. Currently there are 0 such numbers that I've counted, but now one by one I'll start counting more numbers. So I'll put in digit equal to LB for every digit starting from LB, digit less than equal to UB, and digit plus plus. I'll put in a digit at this position now. Okay. So let's say I put this dig at this position. Also remember that dig could not be equal to x unless leading zeros is equal to 0, right? So let's say if digit equals to x and leading zeros is equals to 0, in that particular case this is a violation of the rule, because I'm not filling in leading zeros, and let's say I filled in a 0 here, a 0, okay, this was a 1, and I was currently filling in this position. I put in a 0, but the previous guy was also a 0. This is a violation. I cannot afford that. right? So if digit equals to x, the previous guy, and leading zeros is equals to 0, these are not the leading zeros, these are zeros which will add value to my number, right? In this particular case, this is a violation, so I should avoid that. So just avoid that by typing in a continuous statement, ignore it. And in the other cases, you put in a dig here, okay, and then you see, you put in dig here, and then you see how many n minus 1 digit numbers are there that can follow this, and add them to the answer. That's it. Okay, so I put in a dig here, and then my answer will become plus equal to how many n minus 1 numbers exist. How many n minus 1 numbers exist? So that the previous digit was dig. Leading zeros is going to be what? So see, when will leading zeros be 1? If leading zeros were zeros, there is no way of it becoming 1 again, right? But if leading zeros was true, then this means that till now I have only put zeros, right? And if I put in a 0 again, then leading zero stays 1. Otherwise, leading zeros becomes 0, right? So if leading zeros is true, that should be one thing. And the digit I just put in is also equal to 0. In that case, leading zero stays true. Otherwise, leading zeros becomes false. Similarly, for tight constraint, if tight was already 0, that means there's no possibility of me exceeding the number, then tight stays 0, right? Otherwise, if tight is already 1 and this digit is also equal to the corresponding upper bound of the number, then tight stays 1. So tight would stay 1 if tight is already 1, and digit equal to upper bound. Okay, that's it. That's the entire code, I guess. You can now return. Whereas if I tried my best to, actually it gets a bit redundant speaking the same things again and again, I guess. But I did try my best to explain, so hopefully this helped you. Otherwise, ask me in the comments. Okay, it's incorrect answer. I'm quite proud that it didn't give me a very, very incorrect answer, but it's fine. Let me see what could be the problem. If n equals to 0, return 1, you have generated a number, that's okay. And you subtract these here, that's also okay. Let me print out the string A and also the string B. $122, okay. 3.1, that's all right. Then there has to be some error in the code, I guess. So what could be the error in the code? You do not put the same digit, leading zeros as 0. You're trying out all the digits at this position. That's all right. Let me try a smaller case. Let me try 11 and 16 maybe. It's giving me the right answer for this one. How about 1 and 10? It should give me 10, I guess. But okay, this is interesting. Tight is okay. This was a character, right? It would become something very ASCII code. It would generate the ASCII code instead of what I want. Yep, now the answer is correct. Let me just insert the DP table and we'll be done. Let me say LLDP. First is for the number of digits. Let me put this dimension as 20. X represents the previous guy, so let me put this as 10 at best. Then we have leading zeros, that is a boolean, so 2. Tight is also a boolean, so 2. Right? If this thing is not -1, that means if I've calculated this in the past, if x not equal to -1 and dp of nx leading zeros and tight is not equal to -1, meaning I haven't solved this subproblem before. Wait, meaning this I have solved this subproblem before. X is not -1. This I'm checking, otherwise I'll get a segmentation fault if I put in a -1 at this thing, right? So if I've solved this subproblem before, do not solve it again and just return the answer. Otherwise, calculate the answer, store it, and return it. Also initialize this array 2 minus 1. Yep, I guess this should now work. Okay. Yep, let me try and submit this. Oops. One wrong answer. What could be the possible reason for this to be incorrect? इनका टेस्ट केस गलत तो नहीं. I don't think their test case will be wrong, but always. Oh, I got it. I got it. I got it. I need to memset the DP table twice, right? Oh damn! I'm really sorry about this mistake. Because once you evaluate this, your DP table is already filled up. So LL answer 1. You need to memset it again. Really sorry about this, guys. And now it's going to be answer 1 minus answer 2. And this should work now. Yep, it's giving me the right answer now, thankfully. Sorry for wasting your time, guys. So guys, make sure to like, share and subscribe, and bye bye.